Let's talk about coal. Currently, we mine it because it's abundant, cheap, and mainly because we can. This kind of because we can attitude was acceptable once upon a time, but in this day and age, with climate change caused by CO2 emissions wreaking havoc upon our pristine environment, it's time to shift our thinking. The Australian government has pledged that by 2020, our CO2 emissions will be 5 to 25% lower than they were in the year 2000. At the current rate, though, we're looking at the very likely possibility of our CO2 emissions in 2020 being 20% higher than they were in the year 2000. So, what's the alternative to coal? The only other feasible energy source able to meet baseload demand is nuclear power. Now, I've noticed that whenever I bring up nuclear fission with anyone, the first word on their lips is Japan, and then Chernobyl, and so on. And fair enough, I'm not surprised. In the space of just 25 years, the world has seen several nuclear meltdowns, both major and minor. Hundreds of lives lost, horrifying environmental damage, and economies devastated. When it comes to nuclear reactors, safety is the primary concern, and should be. I think nuclear fission is great, and I do think it's a solution to the problem of our CO2 emissions. I just don't think we're using the right materials for the job. The most popular type of nuclear reactor is based on using water as a coolant, in order to cool the solid uranium oxide fuel. This is a tad problematic, because if power is lost to the reactor, the water inside flashes to steam, thanks to loss of pressure. In the absence of the liquid coolant, the uranium oxide melts, as does the entire reactor, releasing radioactive fission products into the atmosphere. That's essentially what happened in Japan. The risks of using water as a coolant are an unavoidable part of nuclear power. That is, as long as solid uranium oxide fuel is the main fuel used. But there's another radioactive element that is perfect for nuclear power, called thorium. Just like uranium-based fission, there are zero carbon dioxide emissions. But the really great thing about thorium is that it can be made into a fluoride salt, rather than a solid oxide. The fluoride salt of thorium doesn't need a coolant, which means we can say goodbye to the dangers of conventional reactors. Cold air is blown over a freeze plug, which is a chunk of frozen fluoride salt. So if power to the plant is lost, the freeze plug melts, and the liquid fluoride fuel inside the reactor drains into a safety tank where it can gradually lose heat over time. No meltdown. Water-based reactors require power to be provided in order to prevent a meltdown, but fluoride reactors can just shut themselves down in the case of power loss. And it only gets better. Thorium, the radioactive element that is integral to the fluoride salt, is 4 times more common in the Earth's crust than uranium. Australia is estimated to have between 23 and 25% of global thorium reserves. It's so energy dense that you can hold your lifetime supply of electrical energy from thorium in the palm of your hand. And on a macro scale, in thorium-rich regions of Australia, in an area the size of a footy field, could produce enough thorium each year to power the entire world. The liquid thorium fluoride reactor is capable of almost completely releasing the energy in thorium, with barely any waste. This reduces the waste generated over uranium by factors of hundreds, and by factors of millions over coal power plants. And unlike conventional reactors, the thorium reactor doesn't need to be maintained at extremely high pressures. This means that the containment vessel can be much smaller. The entire plant can be much smaller. And the entire plant can be constructed at just a fraction of the cost of conventional reactors. So, a safe, environmentally sound, cost-effective nuclear energy alternative to coal is finally within our grasp. I urge the panel to seriously consider the many benefits of thorium reactors over current coal power plants. Coal is the energy source of a bygone era, where environmental concerns always came second to the profit margin. Thorium is the emission-free energy source of the future that balances the fiscal and the environmental aspects to ensure that Australia keeps moving forward.